Hi, let's talk about pharmacology. This will be presented from the point of view of a medicinal chemist. We'll talk about the modes of action, the effects, and the uses. In other words, what makes a good drug. One thing to look for is the percent of the drug that can enter the bloodstream. This is typically referred to as bioavailability. And if you are introducing your drug by an IV, intravenous method, well, you're going to get all of it in there. It goes directly into the bloodstream. You're injecting it right there. Orally, which usually means a pill, it's going to be less. And if you want to get it into an active site in the brain, well, that's going to be even less because you have to pass through the blood-brain barrier. This typically means you need a more lipophilic medicine, a greasier drug, if you will. Now, most drugs are pills. This is where the biggest market is. And getting those to a receptor can be challenging. You've got to go through the digestive system, and that might treat your drug as food and break it down. Our defense systems might treat them as invaders and surround them and break them down that way, even in the bloodstream. And medicinal chemists oftentimes deal with this when making pill-based medicines using Lipinski's rule of 5. This is to make sure it gets to where you want it to be, and it pays particular attention to solubility. You want hydrogen bond donors to be not too many. You want it to be something that is slightly water soluble and not too water soluble. You don't want it to be too greasy either. It needs to dissolve in the bloodstream, but you don't want it to be too hydrophilic. This is a big one, and that's a molecular weight. Typically, you have to have it under 500 grams per mole. It limits the number of carbons that will be available as a pill, and that's a big limitation. But if you go higher than that, the drug might be broken down, treated as food, won't get through the liver intact, and that could be a big problem. This log p-value is typically a measure of greasiness, where if you go above, say, 5.5, you are very much a greasy substance, and it might just oil out, if you will, in the bloodstream, and that will lower its bioavailability dramatically. Finally, you want to have the correct number of hydrogen bond acceptors, donors as well as acceptors. By dialing these things in, you can get a substance which has the right level of solubility and good bioavailability. Solubility, getting through the liver, and most of these really do deal with making sure your drug is not, as some medicinal chemists call it, a brick, something which is just not going to get into the bloodstream. It doesn't mean you have a good drug. Obviously, once you're there, there's all sorts of problems you might have, side effects, dependence or addiction, drug-drug interaction. These are things which have to be investigated through a lot of labor, right? To try to work out all these rare problems, right? What if the person taking it is pregnant or is on another medication, right? Or is currently addicted to another drug? How is that going to affect it? That sort of thing. But if you can work all that out, you're in the therapeutic window. And here's how they measure this typically. For half the population, there are measurements of how effective it is, what the effective dose is for 50% of the population, what the toxic dose is for 50% of the population, what the lethal dose is for 50% of the population. And if you can see through my image there, this is a notorious study called the LD50, which is typically not done anymore. After all, this does involve killing the subject, which is a sad thing. Yeah, if you take these numbers, you can massage them various ways. One way is to look at the therapeutic index, right? If the toxic dose is very high, that's a forgiving thing. If the effective dose is very low, for instance, suppose you need only nanograms of your substance for an average size human, well, that's a very good therapeutic index. It would be very forgiving if it's high. If it's low, you can still use it, but it's very dosage critical. All things being equal, scientists would prefer a very high therapeutic index. That's a little bit about pharmacology.